Hello everyone. Welcome to our talk where we'll show you how we use blockchain for good by tracking the environmental footprint for traditional Indian art forms. I'm David. I'm from Accenture's global Web3 and digital ownership team, and I've been working on various blockchain projects over the past years involving decentralized identity, supply chain, and TLT platforms, and I'm passionate about using blockchain technology to foster social impact and sustainability. And with me on stage is Gaurav from Dharma Life. Please introduce yourself.
I'm Gaurav, Mehta. I run Dharma Life, which is a non-profit working on rural development in India. We work on women entrepreneurship, and I'll talk a bit more about that. We've been working on the blockchain project together for a couple of years now, so it's a pleasure to be here. So let me start briefly by telling you what we actually do, just so you understand the business case. So we are a non-profit which recruits and empowers women entrepreneurs in rural India, and then trains them to become change makers, focusing on two primary goals: on climate change, so reducing emissions and reducing waste, as well as creating jobs and livelihoods. We were established in 2009, and we have a network of more than 20,000 women. Now it's been 4 years. I think 4 years ago we came together with Accenture and created something called, basically a lab called Dharma Life Labs, which is a partnership between an academic institution, London Business School, a design firm, and Accenture. And it basically, this idea came during the pandemic because we had to kind of react to the uncertainty and the issues we were facing and trying to respond to the pandemic. With this kind of unique group of partners, we were able to bring together the skills and kind of the team which could react and create solutions which could be used not only in the India context, but also then for other, kind of organizations around the world to solve development challenges. I won't talk much more than that, but basically we've done 20 projects now, so it's been quite exciting, and that's how, normally someone who's in the non-profit space as an entrepreneur comes together with a developer like David. So that's kind of the context. Okay. So we'll talk briefly about now how we have used, what solution we've developed. So I'll first talk about the problems, and then I think hand over to David in a bit. So the first problem we worked on is textile waste. As you know, I think 100 billion garments, some stats here, 92 million tons of textile waste are generated across the world. In India, India accounts for 8.5% of the world's textile waste, and only less than 1% is recycled. So this is a huge issue in terms of pollution, waste, etc. So what did we do? We created, this framework is a cradle-to-cradle framework. It looks at the different aspects of emissions and of the interventions one could do. So what we did was we mapped for textile waste for rural artisan products the footprint across these five dimensions, came up with methods and process changes to reduce the waste and upcycle the waste as well. So it was both reduction and upcycling. For this, we then basically worked on, once we introduced the processes, how can we actually track and quantify the footprint. So we created this tool which, by mapping the processes and basically think of it like taking pictures at each step of the process of production, mapping kind of what is the footprint and what is the reduced footprint after our changes. So this tool was created, which then tells you, it's a QR code on the garment, it tells you simply what is the carbon footprint, what's the waste footprint, what's the water footprint. So this was one solution we worked on. The second one, we also work on air pollution. Air pollution, as you know, is a massive issue. I think there are many causes for air pollution, vehicle pollution, etc. But one of the most, one of the saddest ones is air pollution from cooking. In India, we have more than 1 million deaths per year because of open fire cooking and air pollution driven by open fire cooking inside a house. You can see how people cook in this kerosene stove format. And they also use kerosene lights. So they create massive emissions, but also massive health issues. Globally, there are 4 million deaths per year from air pollution, just as a stat. So what did we do here? We, quite simply, there's very simple solutions: electric cooking, more efficient burning solutions for cooking, and there's solar lighting. So all you need to do is kind of change people's mindset to use such solutions, and then you're able to reduce the footprint. We use the women entrepreneurs to do that. The problem, though, is then if you do that, how do you actually prove that you did this, and what was the change? So we created, again, a tool to track what people used before. So imagine taking an image at the household. Quite simply, we go to the household, take an image of what they used before. That image is geotagged and timestamped. Then you create a campaign, which is a celebration. You can see the community event. You visit the houses which are most affected. Mostly, females are more affected. Then you create a sales process, and then you do a survey at the end and say, okay, you can see the happy picture on the right where they use the solar light. So that's the solution we came up with. Now the point is that the CO2 impact, you all know, we can obviously monetize the CO2 impact on the carbon exchange or carbon markets, but that varies based on what was the change. Did they change from the kerosene lantern to a solar light? Did they have power already? Was it a woman using it? Various things effectively, and we created this machine learning kind of process where we were able to map the difference, and you can see the calculation on the right. The CO2 saving varies. Now, these are tech solutions we worked on. What are the key issues still? So the issues are that all these things in a non-profit world are paid for either by companies or by foundations or philanthropies or by governments. But the issue we face is, how do we prove to them that we actually did this? How do we create trust? Why? That's for the donors. Similarly, for the women entrepreneurs, they want to work with us. They have to receive the payment for doing this. So the issues here are transparency. They are effectiveness of tracking. Mostly, we don't. When we know the donor, it's easier. But at the beginning, if you want to scale this up, there could be hundreds of donors, individuals or organizations, who want to solve this problem or support it and pay for the carbon benefit. But then, how do you create trust in that context? Normally, what we do today is you send a report, you take a few pictures, etc. We have a call center which verifies, and also we have an auditor then who goes and samples, and let's say they check 10%, right? That could be a desktop review. It could also be a field visit. You probably have all seen the carbon protocols which are existent now from the World Bank, but the cost of actually verifying is hugely complicated, hugely expensive. There were a few scandals recently also. So just to come back, the issue is lack of transparency in data collection. Traditional methods are too expensive. It's difficult to verify, but because it's mostly self-reported data, right? And there's also a risk of data manipulation and misrepresentation. Basically, the record could be tampered with. How do you solve that? So this is the problem we're facing, and let me ask, I think we went with that problem to David and the Accenture team, and I'll hand over to you to see how we solve it.
So, Gaurav, what I heard is that we want to create transparency. And am I correct that creating transparency happens by finding out, okay, how are we able to verify the integrity of any data we collect? And how do we know where the data comes from and who is the creator of the data?
Yes, absolutely.
And that's a perfect use case for blockchain, indeed. I want to start telling you, okay, what is blockchain essentially doing? A quick recap on that. And then I will tell you about the solution we built together to build more transparency in all processes at Dharma Life. So blockchain allows for trust across multiple parties which collaborate on shared data. And it enables traceability and verification in cross-party workflows, payments, and all types of transactions. How does blockchain do that? Blockchain can verify the integrity of any piece of data by storing them immutably. It verifies the sender of a piece of data, which allows us to track uniqueness and ownership of digital objects and assets. If these assets are tokenized, they can be transferred. A transfer of value can happen in the internet. Blockchain enables the internet of ownership. And it determines the order of events. So what actually can we do with our data on blockchain? Which types of storage we can do? So we can anchor data on chain. By anchoring data, we can prove The data did not change once it's been written. It's immutably stored there. And via the timestamps of the blocks, it also allows us for verifiable historical records. We can not just anchor data, we can also prove the origin of data, which provides provenance to see who created our data or who owns digital objects. This gives us the ability to perform owner-restricted processes. For example, to transfer digital assets only when you own them. When you combine these two, you get to tokenization. Tokenization is then standardized tooling. It allows for standardized processes, standardized wallets, standardized applications. So for the people working in crypto or owning cryptocurrencies, you know that standardized tokens are easily transferred. It allows for interoperability. And also, tokenized assets are more secure because the contracts are already audited and also most efficiently implemented by a large group of developer communities. So how would anchoring actually look like? Yeah, there's multiple ways how we can anchor data. We can take this one. So we can write data in plain text on chain. So if we have an asset, yes, let's say we have 50 kilograms of silk, the data representation in plain text could go on the blockchain. So this is actually very easy to verify, very easy to implement, no pre or post processing needed to verify the data, but everyone in the network can see the data, which potentially can lead to privacy or confidentiality issues. And if the data is big, high costs of storage. A second way how data is stored on blockchain, which is used very often, is to hash the data. So we see on the left, our asset would still be 50 kilograms of silk, but the data representation is now just an identifier and a hash across the data. And then this hash is put on the blockchain. So this is actually much, much cheaper, lower storage cost because hashes usually have a fixed size. And you can quickly detect changes without revealing the data. Yeah. But the burden is there's now more complexity involved for verification as you need the original data. And still, maybe the hash could be reverse engineered if you put enough effort. So third way, how to anchor the data would be a combined hash. So multiple assets, yeah, silk, linen, all of that could be combined into a single hash. For example, everything which was processed within a day. And then this combined hash of everything processed within a day comes on the chain. That is, again, much cheaper. And also, the more assets I have, the storage costs stay the same. But it's even more complex to verify these data now. And I need the full data set to verify the hash. So we will see in our solution later how that plays a role. For provenance, simplest way to say, okay, who owns the data is just to add an owner address to the data set. And now this would already become an ownable digital asset. Yeah? One more attribute, who is the owner, which is also immutably stored besides the data, and I can already prove ownership. But usually that would be done as part of a token. So in a tokenized version of a digital asset, the real data is stored off-chain, either in a decentralized network or in a centralized off-chain database, and only the token itself, the ownership connecting the data and the identifier and the owner would be put on the contract. But do we even need tokens for our use case? Yeah. So not every use case needs a tokens. So first look at our requirements. Yeah. So what requirements should be considered when working on a blockchain project? For one's performance, how many transactions can be recorded per second? which differs vastly between technologies. Data privacy, how easily is it achieved that you can store private data on-chain or off-chain? Trust anchor, who in the end is the trusted entity when using our technology? There's also differences. Verifiability, how easy or how hard, how complex is it for users to verify the data you put on different blockchains? Then, of course, what we also need to consider is development complexity. Different technologies have different complex setup, different effort for feature development. And at the end, what is the cost to operate the service? Because there's vast differences in using public blockchain networks or building your own private blockchain network. To our unique own requirements. So what we need is we need to provide immutable storage of data. So the data from the artisans, the data from the invoices in the result-based financing, we need to store them, and we need to store them immutable so that they can be audited later. And that data must not be readable by the public or unauthorized personnel. And we want cost-efficient scalability for the future, because we think we will have many, many more female entrepreneurs on our platform over the next couple of years. For our nice-to-haves, we would like to run the solution decentralized in the long run, as you know blockchain projects should be, but usually they start centralized. It would be nice if users could verify the data in third-party services and don't need to trust us that we verified for them, that they verified their own, like you probably do with your crypto data on platforms like Etherscan. And we want to avoid vendor or technology lock-in. We said, okay, we also want to have the application or the platform ready for future use cases, for example, tokenization. But of course, you shouldn't always plan too much for the future, therefore I put it in gray here. So what ledgers could we use? So first of all, there's the regular table-based databases, but they're not inherently immutable, so don't spend too much time on them. You probably know about private blockchain consortia, where consensus is enforced across multiple parties, and usually it's trusted participants in a proof of authority consensus. But in our case, there are no multiple parties which could run the nodes. Yeah, so we are Dharma Life. We need to increase trust in our system. So this is not a fit for us either. There's public blockchain projects, blockchain networks. They are highly decentralized, unpermissioned. Everyone can partake. And I just need to pay a dynamic fee. I don't need to set it up myself. So we want to consider this for later. And as a last option, there's also centralized immutable ledger databases. So they provide a temper evidence storage by also chaining data, chaining transactions, but they are centrally controlled by one entity. They are not distributed like a blockchain is. But we want to consider that option too. So, which option comes out on top? So we evaluated two technologies. So one immutable database, the Amazon Quantum Ledger database, and one public network, Polygon Proof of Stake. Both provide a mutable data store, so that's a good fit to begin with. Data privacy, since AQLDB is a private service, yes, data privacy is given. For Polygon, yes, data privacy is possible in the public network, but you need to implement solutions yourself, you need to encrypt yourself, so it becomes quite more complex, but it's possible. Cost-efficient scalability is given, as any other AWS service, easily scalable, basically automated. This is also possible for public networks, but it also comes potentially with hiccups or with some cost involved. What about the trust anchor? Who do we need to trust if we use a centralized service? So for data immutability itself, you need to trust AWS now, because AWS says, okay, this is a service which is immutable. You need to put trust in AWS. But for data availability, you would need to trust Dharma Life. If Dharma Life doesn't pay anymore, that would just be deleted by AWS at some point. The trust anchor in a public network is quite good because you trust the whole global network. With AQLDB, yes, you have a vendor lock-in, centralized service. Polygon is probably a EVM-based network, open source clients, so you can go and leave whenever you want. Verifiability is still hard on both of them. Yeah, more on that later. Development complexity, AWS service is probably good, very well documented. If you use a third-party service to interact with blockchain, it's easy with any blockchain to connect. Just use an API wrapper. If you run the node yourself, it could be quite complex to run the node. So our first solution, yeah, let's use QLDB. Yeah, seems like a good fit, as we see here. It's just one centralized database. It provides us immutability, yeah, and whenever someone wants to verify data, they don't need to trust just Dharma Life. They know that they also can trust AWS as a service. So, but now is the question, can we improve these? And yes, you can build on top of this, because you can build a hybrid approach. A hybrid approach could, for example, store every transaction in an immutable database, and then periodically, like once a day, you could store a whole digest of this database on the public blockchain. So that's what we saw before in anchoring, that we create a hash across all data in QLDB, one single hash, and we put that on blockchain. And what that enables us is that now the trust anchor grows to the whole network. Yeah? So I can rely on the whole network that the data will not be changed afterwards again, instead of just AWS or Dharma Life. For the vendor lock-in, yes, it's improved a little bit because there's also a trust anchored elsewhere. So I could actually switch, but it's quite complex. And this is actually a very recent topic, because this summer, QLDB was actually marked as deprecated. So it's not that usual that AWS services will be deprecated or will move away, but actually it happened. So last year, we decided for that technology, now it's deprecated, and at some point, we need to move. But since we are putting proofs on the public network, this makes our situation way better. Verifiability is still complex on both of them. Yeah, so if you provide a front end for them, it's easy, but for a non-technical user, this is still quite hard. So now we built that solution, and now we thought, okay, can we reuse that knowledge? And we thought about, okay, what about building like a platform for future use cases? A platform which allows us to deploy and operate decentralized applications across a best practice platform. So without the need for specialized blockchain infrastructure knowledge in each new project, in each new team. We could create a one-stop TLT solution for shared endpoints for users to interface with the applications, for admins to deploy contracts, to upgrade contracts, shared knowledge databases. First and foremost, no fragmentation or isolated solutions across my company or across a wider ecosystem. This allows us to be really, really efficient with the development of new blockchain-based projects, because it will be much more cost efficient if you can reuse what you've already built. In addition to that, we want to integrate specific embedded capabilities which we use alongside blockchain. For example, machine learning, what Gaurav told us about, where we want to create visual proofs via image classification to see which products has been sold by the entrepreneurs. So how could such a platform look like? So a platform could look like this, that Dharma Life could host multiple applications in their own namespace in a shared platform. This shared platform has interface API services, secure key storage, storage services, and a scaling layer. Everything you need for a blockchain project is already there. You just reuse it and you potentially choose your technology of choice. If in the future you want to choose modern layer 2 rollups, go for it. If you want to use centralized immutable database, it's just a click away. And then you decide, what is your trust layer? Will I put my proofs, will I put them again on Polygon? Will I put them on public Ethereum mainnet? So you can build many, many interfaces that users can build platforms on top of this. But not just Dharma Life could do that. Also, other non-profit organizations could be provided with this TLT platform infrastructure so that they could build the token use cases of their choice. Then to build this, you need like a lot of effort, a lot of knowledge, yeah, a lot of technicalities. Yeah, you need unit tests, templates, access to test nets, API wrappers, pipelines, technologies for nodes, smart contract language. Yeah, so why not reuse what you're building? And yeah, that's the platform. And I think we want to show the application next. Let's watch a very short video how the application looks like.
So I think you have one more time, I think, to play. Yeah, so you can see here, I think the first one was the garment application for the textiles. So you can see after the QR code scan, you can see kind of per garment is an art form for weaving. So it actually shows the steps of each process. So imagine the different artisans have actually access to the platform and upload. And it's captured, the way it's captured is basically that you kind of create a style. So this is very basic, but the whole point is that the image-based, so it's image-based verification and geotag-based verification, and we have built algorithms to calculate kind of what is the footprint for each item. So you can see unique IDs are created, the fabric, how much fabric is used is tracked, and yeah, there's a full life cycle process around this, where you kind of look at the emissions at each life stage, including up to from the thread up to the packaging. So this is just a few examples on what are the ways it's capturing. And then a record is created for each step. The other interesting thing, which I didn't mention earlier, is that as a customer, you can actually then see each step. I mean, we're trying to now figure out how much of this goes into the public side and how much of this goes to stays private. The other thing, you never see who actually made the product, so we actually thought it was quite cool to add the story of the artisan and who the person was. That's kind of summarizing this tool.
Cool.
I think that's it. And
yeah, thanks, Gaurav. Could you give us an outlook?
So I think just a couple of final points. So we have a large network in India across 40,000 villages. So first step is we are scaling up the solutions, both the use cases across our network. I mean, we have a network of 20,000 women who are going to kind of do this. We started now with a few hundred. I think so far 10,000 transactions have been tracked on the platform. That's the first point. The second thing is we want to make the platform, kind of different parts of it agnostic and roll them out, share them in a SaaS format to other nonprofits. But it doesn't also actually need to be nonprofits. We actually have had now examples of a Unilever or a corporate who wants to do the verification across the supply chain, or others who have their own solutions, but the simplicity of this kind of makes it easier. The other thing we're looking at is integration with other kind of ecosystem services, Google for GPS, or basically others to aggregate, because some of the work as well as auditors. And finally, there's a technology enhancement plan, which I think it's more about actually building out the token use case, having a kind of a use case adapted platform. We can use the backend. I mean, the similar sort of structure for new use cases, and there's a lot of work on ledgers now that. Please do.
Yeah, definitely. There's a lot of work in front of us, and yeah, let's hope that over the next months we achieve a lot.
Thank you.
Great. Thanks for listening. Let's jump to the questions. What is the environmental footprint of such solutions? So the environmental footprint in terms of blockchain is not any other different than conventional ID solutions. Yeah. So many people, when they hear blockchain, they think about Bitcoin, and Bitcoin, which uses proof of work, loses a lot of energy in the process of mining the blocks. Yeah, it's important that Bitcoin does that, but of course, it's not good for the environment. But these other chains, many other chains, run on different consensus mechanisms, which are much more energy efficient. So maybe you can say something about the solution itself, Gaurav. I don't know, any other environmental impact of the applications of the apps?
Actually, if you look at it, we are reducing travel, right? Because we are actually decentralizing the capturing of the data, and we're using kind of ML-based verification tools to verify the data which comes straight from the last point, right? The artisan or the different steps in the value chain. So that is reducing kind of visiting footprint. I mean, normally the team would go and visit. So that's one thing. But otherwise, I don't think there's any additional footprint, David. I think that's, as you mentioned, I think as per common.
Yeah. Great.
The other one, iPhone, I can answer that.
Is the project also working on iPhone, Gaurav?
So iPhone penetration in India is still very limited, but what we've done is we've created a web application which is browser-based or Chrome-based. So for that would work on an iPhone. We've not created an iOS app because the iPhone penetration in the village area is less than 1%, I think. Or it'll change, but I don't think the backend will be the same. We'll add that application when it's required.
Cool.
Yeah.
Do you plan to open source parts of the platform to further create trust amongst users?
So, should I?
So yes, open sourcing certain parts of such a platform would be crucial. So now it depends who are the users. Yeah. So if the users are the entrepreneurs, you would need to evaluate, okay, how much they would actually look into open source as a requirement. For the donors, maybe, yes. Certainly not the whole stack needs to be open source, but especially how you store cryptographic material and cryptographic processes around that. That helps a lot in gaining trust in open source. That's completely correct.
Yeah, I mean, ultimately we are working for public good, right? So that's why whatever is necessary and helps to kind of create trust or create more adoption. For us, this is like a digital public good which we're trying to create.
Yeah, great, cool. Any more question ad hoc? Don't be shy. No? Then, yeah.
Thank you very much.
Thank you everyone for listening.